Today's class I am going to discuss about how to implement XOR gate and XNOR gate using only NAND gate. So previous video we discussed NOR gate, AND gate, OR gate, NOR gate using only NAND gate. Now we move on the session. So how to implement XOR gate using only NAND gate? First I draw the symbol. So it is a symbol of XOR gate. Input is A and B. Output of the XOR gate is A XOR B. Now I write the abbreviated form of the expression A B bar plus A bar B. So it's a Boolean expression. Now I am going to draw the structure for XOR gate equivalent NAND gate. So using NAND gate means first the output Boolean expression is changed in the form of dot operation. So in that purpose I am taking double bar in this output expression. Now I am applying the De Morgan's theorem. Break the bar, change the sign. So A dot B bar dot A bar dot B the whole bar, then whole bar. Now the given Boolean expression is converted in the form of dot operation. Using this expression, now I am going to draw the NAND logic structure. So first input is A. A is connected to first NAND gate input. Then second input is B bar, but actual input is B. So this input is given to NAND inverter. The output of the NAND inverter is connected to input of first NAND gate. So this NAND gate number 2. So second NAND gate output is connected to first NAND gate second input. So this term is over. The output of the first NAND gate is A dot B bar the whole bar. So it's the output of first NAND gate. Then come to the second product term. So here actual input is A, but I need A bar. So this A is given to third NAND gate. So it's a NAND inverter. Output of the inverter is A bar. So this output is connected to fourth NAND gate input. Another input is B. So B is connected to second input of fourth NAND gate. Here output is A bar dot B the whole bar. So far we obtain these two product terms. So next step is just multiply these two terms, then take the complement. So using one more NAND gate for taking product of these two values, then complement of values. So A dot B bar the whole bar dot A bar dot B the whole bar, then whole bar. So this expression is implemented in using NAND gate. So now I prove this expression is equivalent to XOR expression. A dot B bar the whole bar dot A bar dot B the whole bar, then whole bar. I just apply the De Morgan's theorem. So break the bar, change the sign. A dot B bar the whole bar bar dot A bar dot B double bar. So this double bar cancel. So this is the plus symbol. A dot B bar plus A bar dot B. So both the expressions are same. Then come to XNOR gate. So XNOR gate means just take the complement of XOR gate. So it's a symbol. So only I add the bubble symbol from this XOR gate. So input is A and B. Output is A XNOR B. The abbreviated expression is A bar B bar plus AB. So it's a abbreviated expression for XNOR gate. So first I convert this expression in terms of NAND logic. So in that purpose I am taking double bar, A bar B bar plus AB double bar. Apply the De Morgan's theorem. So break the bar, change the sign, A bar B bar the whole bar dot AB the whole bar then whole bar. So using this expression now I am going to draw the NAND logic. So actual input is A, B. Now I need A bar and B bar. So I am using two NAND inverter. So output of the NAND inverter is A bar and B bar. Then take the product of these two variables. So these two output is connected to third NAND gate. So output of the NAND gate is A bar dot B bar the whole bar. So we obtain this term. The next one A dot B the whole bar. I just take two input from A and B. These two input is connected to the another NAND gate. So output of the NAND gate is A dot B the whole bar. So now this term also obtained. Just you multiply these two terms. So just you apply the product term between these two terms. Then you take the complement. So this operation performed using another NAND gate. So now output of the NAND gate is A bar dot B bar the whole bar dot A dot B double bar, sorry, A dot B the whole bar then bar. So this expression is equivalent to this one. Now I prove. So A bar dot B bar the whole bar dot A dot B the whole bar then bar. I just apply the De Morgan's theorem. So break the bar, change the sign. A bar dot B bar the whole bar plus A dot B double bar. So this bar cancel. The final answer is A bar B bar plus AB. So these two Boolean expressions are same. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make lot of videos. Thanks for watching my channel. Thank you.